Hello, we are going to our next segment in basic concepts of general chemistry. The topic now is scientific method, measurement, units and dimensions, significant figures, and we will solve some problems during the lecture and some lesson check questions will be there, both theory and numericals. After the lecture is done, the students are needed to solve them on their own to build a strong concept. So let us start now. Scientific method. What is that? Every day we observe some or other thing happening, some natural phenomena, some physical phenomena, some chemical phenomena, like cloud forming, rain, and then some flower is blooming, or maybe we do not see how a flower blooms from the very start to end, but we can see the flower once it has bloomed. Then cooking, uh, from fresh vegetable, how they are turning once cooking is completed. Then how on switching on the fan or AC or light, how light is glowing, how fan is rotating, or how the AC is cooling the room. We see some or other thing. Sometimes we think about the phenomena, how that is happening, why that is happening. Sometimes we do not. Now, scientific method is about observation, not only observation merely, but gathering data and then noticing patterns in that data, some repeating pattern or the trend of the data at least. From that pattern, some hypothesis is formed, which tentatively explains the observation, why that is happening or how that is happening. Now, the hypothesis is merely based on our prior experience. That may be correct, may not be correct. So, to see whether the hypothesis is correctly framed or it is wrong, experiments are needed to be carried out. So, whatever phenomena is observed happening spontaneously, now they should be carried out under controlled conditions. Then again, data is to be gathered. That data will be gathered from that experimentation and they will be analyzed so as to interpret the result of experiment. And then this will be compared with hypothesis. Then if the hypothesis is proven to be correct, then theory will be developed with broader explanation that will be supported by repeated evidence. That means the experiments are to be repeated and reproducibility of the result, reliability of the results should be checked. Not only one time that is obtained. Reproducibility, reliability is very much needed to go up to theory from hypothesis. Okay. Now let us see some example. We all have seen rusting of iron. Now the observation here is iron objects left outside turn reddish brown, which is called rusting. Now, hypothesis behind it is rusting occurs due to oxygen plus water. In presence of both oxygen and water, rusting takes place. Let us see how the experiment can be planned. So whether oxygen and water both are needed, that should be checked. Whether any of these are needed, that should be checked. So nails can be put in bottles or sealed jars where vacuum is there, that is no air, or it may be nitrogenated environment or carbon dioxide environment where air is replaced with these gases, but oxygen is not there, neither water is there. We may have some jar where dry air is there. That means oxygen is there, but water is not there. We may have some jar where water is there, sealed bottle where no air is there. And we may have some jar where water and air both are there. Now, the gathering of data comes up, means we need to gather data. So we need to observe these bottles for some time. And once in any bottle rusting takes place, obviously in the bottles, iron nails will be placed in each bottle. Okay, so in any bottle rusting is taking place, we will wait for some more time to check if any slow progress in other bottles are going on. If you carry out this experiment, you will find that rusting forms only in the jar where both oxygen and water is there. In no other jar, you will find rusting has taken place. All nails will be fresh and fine. So, we can, after analyzing this result, we can conclude that rusting requires both oxygen and water. Thereby, the hypothesis is proven correct. Hypothesis is supported. So, theory based on that can be obtained after writing the chemical equation. You will find that once we go further in our course, we will learn the redox reactions, the type of reactions. You will find, once we complete till that part, you will find that this rusting of iron or corrosion is an electrochemical redox process. That is the theory. It's not only for iron, it is true for any other corrosion event. So that scientific method cycle, how it is going? Observation, hypothesis, experiment, theory. So this is the scientific method cycle. Okay, identify a problem, research your problem, develop your hypothesis, design an experiment, collect and analyze result, construct a conclusion, and thereby you are having this whole hypothesis proven or nullified. So first of all, firstly, observe something carefully, make an observation, and then go on with the cycle. And this should be repeated before framing the theory so that you can check the reproducibility of the results, reliability of the experiment. Okay. Now going to the next thing. That is another very important thing, that is measurement. Whatever we are doing, we are observing, we are experimenting and gathering data, it's all about measurement. What is measurement? It is quantitative description of matter. Not only matter, quantitative description of event. Like when we are saying how much time has passed, we are not quantifying matter. We are quantifying one coordinate, time coordinate, right? And for measurement, two things are very important. One is accuracy, another is precision. What is accuracy? It's the closeness to true value. And precision is reproducibility of the results. Reliability of scientific data depends on proper measurement. Now, what is accuracy and precision? If you want to understand this dartboard drawings or images, you can observe carefully. The first one is showing accurate and precise aiming. That is, all the targets, all the attempts have hit the target. So accuracy is definitely there and precision is there because every time it is getting repeated. Second one, it's precise because whatever aiming has been done, the target is not hit, but wherever it has hit, it is at the same point or near about. Right. So it is precise, but far away from target. So it's not accurate. And third one, it's neither precise nor accurate, obvious because it is far away from the target. And every time it is going to new point. It is hitting new point. So it's not precise as well. Now for measurement, two more things are needed. One is some standard. We don't have any absolute measurement. We always compare with something. When we are saying 1 kilometer distance, it's about comparing the distance with a standard distance that is a meter. So that standard is known as unit. And one numerical, that is 1, that is added to that unit or that is quantifying that unit, that how many times that unit should be multiplied to get the actual distance. And when we have talked about kilometer, there is a prefix to meter, kilo. So let us see all these things. Units, there are several systems of unit, but throughout the globe, one standard unit is used, that is International System of Units. It has two types of units, base units and derived units. This base unit or fundamental unit define those quantities which are basic quantities, fundamental quantities. And derived units, some relationship among the fundamental quantities will give us some more quantity, and those units are called derived units. We will learn these things in our next slide. And dimensional analysis. Dimensions, when we are talking about, whether we are talking about mass, we are talking about time, and what is the order of that? That is dimension. Or what is the power raised for mass, time, or any other thing, distance, length. So that is dimension. And why dimensional analysis is needed? It is needed to check consistency of the equation. I was talking about prefixes to units. These are the common prefixes which we use before the unit so that we can measure very small, very minute things or very big things. Light means, let's talk about light year. What's that? It's unit of distance. In 1 year, how much path, how much distance light will cover? That is light year. That is used to measure distances among planets or the stars, right? What is used for very minute things, say nanoliter. It's 10 to the power minus 9 liter. So to measure a tiny drop of liquid, maybe. So these are the prefixes commonly used for smaller things, that is very small things. You will be using 10 to the negative power, and for bigger things, you will go for exponential things like 10 to the power to of 10, a positive power of 10, right? Now we were discussing about fundamental and base units. 7 fundamental units are there: length, mass, and you will see the SI units by the side of the quantities: length, mass, time, temperature, amount of substance. Now you may be confused. You may get confused that once we are talking about mass, once we are talking about amount of substance. Mass is how much is there, and amount of substance means how many are there. Like mass means collectively how much is there. And amount, when we are talking about in terms of mole, that means how many molecules, how many atoms, how many ions, or in general, how many radicals are there. Number of units. Okay. Then next one is electric current. So, and the last one, luminous intensity. These are the 7 fundamental units. All other units are derived from this. It is that will be derived units. So SI base units are given, which forms the foundation of all measurements. Derived units, example, let us see. Velocity. Velocity is measured in terms of meter per second or length per unit time or distance per unit time. Force, Newton, which is again derived unit because 1 Newton is equal to 1 kg meter per second square. Pressure, energy, the units are given by the side. So derived units describe physical quantities based on relationships between base units. Significant figures, another important thing that should be considered while measuring something. Like when we are measuring 1 meter, is it 1 meter or 1.1 meter or 1.11 meter or 1.111 meter, 1.9 meter? Can we round off it to 2 meters or 2.0 meters? So what number of figure we should use while stating measurement of some particular quantity? So this actually indicates precision of measurement, accuracy of measurement, how accurate the result is. So all all non-zero digits are significant. All non-zero digit in any measured quantity are significant. Zeros between two non-zero digit are significant. So any zero coming in between, number of zeros between any non-zero digits are significant. Leading zeros will not be significant. Trailing zeros are significant only if decimal point is there. So these are used in scientific calculations to avoid overstating precision. We should be precise, but not too much. Too much of anything is not good. Now let us go for solving some numerical problems. So the problem statement, the first one is about derived units. The problem statement is the force applied on a body of mass 5 kg produces an acceleration of 2 meter per second square. Calculate the force in SI units. So let us go for the solution now. How can we solve? So first we need to write an expression. What is asked and what are the things given? What data are given? So expression should include all these things. That means a relationship should be established between what is being asked and what data we are having in our hand. Here mass and acceleration are given and what is asked? Force. So the expression should include force and mass and acceleration. So force is equal to mass times acceleration is known to us. So now next step is to substitute the data in place of the quantities. So mass is 5 kg. So we are substituting 5 kg for mass and acceleration 2 meter per second square. We are substituting 2 meter per second square for acceleration. One important thing is to be considered here. If units are not in consistent system, like if they are not in SI system, we should bring all of them to SI system, and for that we need to convert them. Some conversion factor is to be multiplied. That is very important. So after calculation, we are getting 10 Newton. Already in the previous slide, we have seen 1 Newton is equal to 1 kg meter per second square. So derived unit of force is Newton, which is equal to kg meter per second square. Next is about unit conversion. Just now I talked about that. So the problem statement is convert 72 kilometer per hour into meter per second. So first we need to know the conversion factor for kilometer and meter, hour and second. So 1 kilometer is equal to 1000 meter, or 1000 meters make 1 kilometer. So that conversion factor should be multiplied. And 60 seconds make 1 minute, 60 minutes make 1 hour, or 3600 seconds make 1 hour. So we need to use that as well. So we are getting, and since second is coming in the denominator, so 3600 second will come in the denominator. So finally, we will multiply and divide to get the final answer, 20 meter per second. Now, next one is about dimensional analysis. The problem statement is check whether the equation V is equal to U plus AT is dimensionally consistent. Now, what is V? V is initial velocity. Sorry, I'm so sorry. V is the final velocity. Please mark this. It was my mistake to say V is initial velocity. V is the final velocity. U is initial velocity. When we are observing some object moving, we are noting the initial velocity as U, final velocity where our observation ends, that is V. And A is acceleration. T is the time taken to reach V from U. So now we have to check whether this equation is correct, dimensionally consistent. If it is dimensionally consistent, we can say this is correct. So the solution goes like, first we need to write the dimensions of the left hand side, then of the right hand side. So dimension of left hand side, length per time. For right hand side, for acceleration, for U again it is length per time. For acceleration, it is length per time square. And for time, obviously it's time. So if you multiply acceleration times time, it will be LT inverse, same as the left hand side. So both the terms have dimension. Both the terms means both right hand side and left hand side are having the dimension LT inverse. So the equation is dimensionally correct. Now we will solve some numerical on significant figures, or in short we can say sigfigs. Usually students say that. So the problem statement, let us see, add 12.11 plus 18.0 plus 1.013. So simple addition will give us 31.123. Now to obtain the correct answer, correct number of sigfigs in the answer, we need to round it off it to 31.1. Why? Because list number of significant figures given in the question is 3, 18.0. So we have to go for that. That is, list precise decimal place is in 10th. So we need to go for that. So final answer will be 31.1. Some more on sigfig. Multiply 4.56 times 1.4. So the solution, 4.56, 3 significant figures, 1.4, 2 significant figures. If you multiply, you are getting 6.384. 4 significant figures. The answer should be rounded to 2 significant figures, that is the list number of significant figures present in the question. So final answer will be 6.4. Why 6.4? If the whatever the number of figure you are rounding off, that is the last one, that is 3 here, you are going for 3, but any figure after that, if it is 5 or more, then it should be rounded off to next digit. That is, next means you can give increment of 1. That is, 3 will be incremented to 4. So 6.4. What are the steps? So now lesson check questions. These are to be solved by or answered by the students or learners. After the lecture is over, after you have understood, then check yourself whether you have got the concepts, perceived the concepts. So, what are the steps of the scientific method? Define accuracy and precision in measurement. Give examples of SI base and derived units. Apply the rules of significant figures to the number and find out the number of significant figures here. Convert 90 kilometer per hour to meter per second, and you will be provided with some questions. If you are interested, you can solve them and you can ask for your doubts also. Stay tuned. Our next topic is coming up soon. Thank you.